Right. So hello friends, I'm Michael from Google. I want to talk about paint timing, potentially exposing more paint timings. Quick summary of the problem. There are several specs that expose some concept of paint timing, also known as render time. Good segue from the spec. And there are, I think, several reasonable interpretations of when to mark this timing. I think it's a bit underspecified, and we already have interrupt differences across implementers. Now, the last point is interesting, which is that I think that multiple time points are interesting and important for developers, or could be. And so there might not just be a single ideal value that we need to sort of button down and settle on. So wanted to discuss some of the motivations there. And the goal for today, I have no specific proposal that I'm making. It's just wanted to drive towards clarity. In particular, this issue has come up over and over. I think there's terms that get mixed up, and Sean's been working on LCP over at Mozilla, and some of these questions have been very recently brought up again. So I'm trying to hope to drive towards consistency in terms and understanding. Okay. So paint timing attempts to mark the point in time when the browser renders a given document. Now those terms are kind of loosely interpreted by us. Of course, we have mark paint timing at a very specific step in the HTML update rendering. This is exposed through the start time value, which is relative to time origin, and duration is always 0 on the event timing or the paint timing entry. Largest contentful paint builds on that and builds on top of element timing. It exposes load time of the element as well as the final render time, which is a different modification to HTML. And then the start time value of largest contentful paint may or may not be the render time, depending on whether it passes tau check. Element timing is the same as LCP because it's built on top of that. The one thing I wanted to call out is LCP is implicitly document timeline starting at time origin, but individual elements have implicitly a non-zero time origin, or at least they could. So you might use resource time and start time of when the resource began fetching. You might use the moment in time that you added a resource to the DAO if you're tracking it yourself. So there are, and then finally there's event timing. So event timing exposes the start time of the event, its timestamp, as well as the duration, the total time it takes to render that event. But the start time plus the duration is effectively a render time. We expose a few more time points, and we modify HTML in a different way to expose those values. Okay. So interop issues aside, there are some different definitions there. So I wanted to start with a quick example showcasing where it can be confusing. And that is, how do you do paint timing and image decode? So the task is to load an image, decode that image, render that image. I built a test page, and I used 3 different strategies. So you can create an image, make sure it's loaded, and use the decoding equals sync attribute. You can use decoding equals async, or you can explicitly call decode and wait for decode to complete before you attach it to DOM. Okay, and I used FCP for testing since it's widely supported. So the easiest of those is the last one. So in the last case, you wait for the image to load, wait for the image to decode, attach it to DOM, wait for rendering and presentation. So it's to the best of my ability, and it is tough sometimes to sort of mark these timings and do a visual film strip and try to backward roll. I don't understand all of the rendering pipelines as well as I'd love to. Hopefully we can work on that today. These are the timings you will get. The size of these boxes are not really proportional to how long these things take. Obviously, loading and decoding of images tends to be a lot larger than this short rendering task and the delay for presentation. So the difference here is not incredibly large. If you set the attribute decoding as async, what happens is that the image will be loaded, you attach it to the DOM immediately, and we will proceed with render and presenting the frames, not waiting for that decode to complete. On all of the browsers, that means that you will see a visual update to the page without seeing the image decoded if decode takes a long time. And it can take a long time to decode the image. Okay. So decode async does not speed up decoding. It's not a performance improvement necessarily. It's saying that I don't need you to wait for this image to decode for rendering frames. So in this case, it actually gets labeled very similarly, but it ends up being kind of decoupled from when the image becomes visibly available. As far as I'm aware, on all implementers. There are some open issues to solve this problem to actually track the time it takes to decode async images. And the last case is the most common case, which is decoding sync. This is not the default. The default is auto, and there are some differences. As far as I'm aware, on Firefox, the default is async. But if you explicitly ask for decoding to be sync, it's kind of swapped from the first example I showed. So you load the image, you wait for it, you ask for you attach it to the DOM, you wait for rendering to happen. That will kick off a decode and then finally gets presented. In this case, decode on all browsers, as far as I'm aware, is actually async. Don't do decode on main thread. It's not blocking, not anymore. But we wait before showing there will be no render, no presentation until that decode is complete. That is the difference. So these are the time points, as far as I'm aware, that I figured out. Safari's a bit different. And it might actually be similar to Firefox because, to the best of my ability in testing, there are two different rendering tasks that will happen with an async decode. The initial rendering task that discovers the need to paint an image will kick off some decode work. And then a future rendering task will, once that decode is complete, will actually try to render the image. Okay. So there are two rendering tasks, or two paint opportunities that are co-involved in a sync decode opportunity. So there's mark paint timing, but which paint? As far as I'm aware, it might even depend on conditions of the page. I had seen some evidence to suggest that Safari uses the second rendering opportunity, but then also saw lots of evidence that uses the first. I believe Firefox also uses the earlier time. What that means is the timing that's marked for images that are sync decode will be the time it's attached to DOM, not the time that it actually gets rendered on page, even though there's no rendering work that happens. Very early, basically. Possible I got some of this wrong. We could work it out. The point is that there are differences and that it is complicated. This has been noticed by others. Tim Kadlik wrote a really nice blog post a while back talking about why first contentful paint, it doesn't work as a cross-browser metric. And he pointed out some time differences between if you use film strips to analyze and use the metrics that are shared, how there are differences. One thing I'll point out is that the difference on Firefox between the FCP reported times is pretty small, but I think that's a side effect of the fact that there's default async decode. And so the FCP values here, I believe, to the best of my ability, were for other content on the page, not the image. The image was more similar to Safari, that it took much longer, where Safari is default sync, if that makes sense. Okay, so why is this so difficult? Why are these values so different? Well, according to spec, plus all of the patching that we do in the spec, there's this linear process for how to do rendering and where to mark paint timing. It should be pretty obvious. But that step 16 is pretty big, pretty bloated, and pretty underspecified in general on how we do rendering. And in reality, this is what rendering looks like. This is the architecture of Chromium. Rendering in G architecture, there are multiple threads involved, pointers, back pointers, iterations, loops, and stuff like that. Firefox, I believe, is very similar. I couldn't find a diagram like this for Safari. I'm sure it is complicated as well. Chris Harrelson wrote up a really nice summary about how to interpret the event loop steps and especially the update to rendering steps and how the implications are that it must happen in series, but that there are certain implicit assumptions that allow you to make running many of those steps in parallel. One of those is the principle of script observability, but I think the performance timeline is in violation of this principle right now. if that makes sense. Anyway, this is just some of the background. And there was some discussion about like, could this be solved differently? Apparently the original paint timing implementation in Safari did expose something more akin to what Chromium is doing. But because of this spec problem of not being specified, it was changed. So it is possible if we did it. Okay, so image decode is, I think a lot of us were bitten by those differences, and so I wanted to talk about that, but it goes beyond image decode. I myself have been focusing on event timing through our efforts on interactions next paint and working on responsiveness. The goal for events and event timing and responsiveness is more to be under 100 milliseconds of latency for interactions. And you should never be above 200 milliseconds. What that means is it's a much tighter timeline as relative to something like first content full paint, where you have much more time to get those renders. So the small differences in what's measured make a bigger impact. And when looking at what affects like performance pitfalls for event timing, what actually affects long events for responsiveness, there are many things developers can do to shoot themselves in the foot or to have issues. From, of course, input delays and processing times of event handlers, but all of the rendering work that needs to happen afterwards. So I marked a bunch of time points from when you finish processing events or when you finish adding elements or loading elements to how long it actually takes to have a new rendering opportunity. There are things you could do to prevent rendering opportunities as a developer. Even once you start a rendering task on the browser, there are things you can do to make that task take a very long time on main thread and block, even before starting actual rendering work. Then there's the time it takes to do rendering work, and finally how long it takes to present a frame, which might include things like image decode, but other rasterization tasks, animations, etc. So for developers, when we say render took a long time, or don't even give them that information, it becomes a bit of a black box in terms of performance, and it's incredibly common that this is the source of problems. So breaking down these time points and these like durations can help sort of narrow down focus as to where to invest time. Perhaps not all of these need to be exposed to field data, but certainly in lab tooling and the way we discuss it in market. There are other issues with multiple time points other than just describing one thing. So we've talked about progressive images, placeholder images, and exposing multiple time points on timing. There are issues right now where first contentful paint can be reported as larger than largest contentful paint when the LCP element is not tau, which should be impossible, but it's just, we have two very far away time points. We fall back to the load time of the image, which is really far. There are also cases where render time is very decoupled from load time. So you may load an image and then wait a very long time to swap it in. And then because the tau check fails, we can't expose render time. But so we fall back to this really early time as opposed to multiple alternatives in the middle. So there are other reasons to consider not trying to shoehorn many different possible values into very few slots. Philip Walton wrote an excellent article about how to optimize INP and tried to narrow focus down into these areas as to like things that tend to affect. And the guidance was that last portion, the element render delay, should just take 10% of the overall CP time. But in practice, even very good sites with very few render blocking resources, no long tasks, nothing, that tended to be much larger than we were expecting. So things are happening that affect render delay, and it's a bit of a black box that our best expert couldn't figure out. And so there's value in being able to dive deeper. Okay, so mark paint timing is technically specified, but not necessarily which paint is responsible for doing work. There are differences. Element timing introduced more timings, and Chromium uses those for its paint timing. And I think that there are many breakdowns which would be very useful for developers, especially so for event timing. But we were surprised to find that even for LCP, these would be incredibly useful. Okay, I think that's it. So a bunch of links to issues with some background information about how we might post some of it.